So today we begin our final topic, polar functions. And obviously the beginning of this you have studied last year, but obviously not the calculator or the calculus, portion of it. So I'll begin with just a little review. Any point in your Cartesian plane can also be considered and defined as a point in the polar plane, instead of being how far the object is to the right and how far the object is up from the origin. We can define it instead as how far out from the origin, and we call that r, and what angle it has, and we call that theta. The angle, of course, would be from the positive x-axis in a clockwise direction. So, for instance, that point up there, P, could be referred to in rectangular coordinates or in polar coordinates. Now, if it's referred to in polar coordinates, there actually can be multiple ways to refer to it. In rectangular, there's only one. In polar, there could be multiple. Just for example, one easy example would be if we decided to refer to this as 2 root 2, comma, negative 7 pi over 4. That's the same place. Okay, so the rectangular coordinates for these polar coordinates, well, there's only one, but I figured I'd at least show you. If we are 4 units away from the origin and an angle of pi over 2, that's right here, 4 units away, 1, 2, 3, 4, and then at an angle of pi over 2, so then that would be 0, comma 4. If we're at the point negative 3, comma pi, well, pi takes me over to here, but then this would be 4, 3, 2, 1, 0. Where would negative 3 be? We'll keep going. Negative 2, negative 3. Now, that's not a definition of the x-axis in general, but if I'm at the angle pi, then I could number this way, and it actually means that it takes me right here. So it takes me to point 3, 0. Well, that means that in polar coordinates, negative 3, comma pi is the same as 3, comma 0, or 3, comma pi in polar coordinates. And of course this down here is in rectangular coordinates. Notice actually they do share 3, comma 0 in both places. Alright, so 16, comma 5 pi over 6. Well, of course I need to change my scale here. Let's let this count as those values. And if I go to 5 pi over 6, that's this last line over here, and that would be then right here. Now, if I want to find the x and y component here, of course, x would be negative, y would be positive, but I can do that knowing that this little triangle in here is, in fact, a 30, 60, 90 triangle. Or I could use unit circle definitions and things I did for vectors, like such as r cosine theta and r sine theta. Those are true definitions, but if you think about it conceptually, hopefully this makes sense to you. The 30-degree angle in here, this will be the short side across from it. So actually I should have been drawing it right here, excuse me. That's a 15-degree angle down there. There we go. This will be a 30-degree angle. So we have a length of 16 here. Half of that length would be my short side, and then 8 root 3 would be my long side from 30, 60, 90 triangles. So then that would be negative 8 root 3, comma 8. Okay, and then if I'm at negative root 2 and negative pi over 4, well, negative pi over 4 is taking me down here, but then negative root 2 takes me all the way back across over here. Somewhere around right there between 1 and 2. So then I'm at a, let me make that triangle a little bit bigger, length of root 2, and then I'm at a 45-degree angle. Well, then that means this must be 1 and 1. So then that means I'm at negative 1, comma 1. Now notice we could give lots of sets of polar coordinates. They're just asking for 2 for these places. Lots of ways you could define them. So the point 1, 0 could actually, oddly enough, be 1, 0. But it also could be 1, comma 2 pi. it could be 1 comma negative 2 pi, or if you want to start getting creative, I could do a negative radius if I took myself across to over here, then took myself back in a negative direction. Okay, so that was Roman numeral 1. Okay, Roman numeral 2, negative 3 comma 3. That takes me to about right here. 3 units to the left and 3 units up. Okay, so then that, if I am in fact 3 units left and 3 units up, well then that radius would then be square root of 3 squared plus 3 squared, also a 45, 45, 90 triangle. So I could have just said that that is 3 root 2. So that's my radius. And then my angle would be 3 pi over 4. Once again, I can mess around with the angles, I can mess around with the radius. I could make this negative 5 pi over 4. I could also do any basic addition or subtraction of 2 pi or 2 pi n, if you will there. I could also get creative and do the negative radius and then take myself over in the opposite direction, like negative pi over 4 or 7 pi over 4. Any of those are fine. Okay, so Roman numeral 3, we're at 0, negative 4. Hopefully this one's a little easier for you. That's a radius of 4. And then the angle could be 3 pi over 2. Angle could be called negative pi over 2, or of course any addition or subtraction of 2 pi n. Or we could go negative radius with an angle across 180 degrees away from it. Supplement, if you will. So 1 comma root 3 takes me to about here-ish. Well, it's a little triangle. I'm going to blow it up for myself here. 1 comma root 3. Do Pythagorean theorem, and I get root 4, or 2. That also would be a 30, 60, 90 triangle, if you're not recognizing it. This will be a 30-degree angle on the short side. So then we know that this is a radius of 2, and an angle of 60 degrees, or pi over 3. Also, sorry guys, if you didn't know this already, I do live close to the high-speed line, so occasionally you may hear that noise as I escape to my front porch to get away from my kids so that they don't make noises on the videos. And let's see, I could do a negative angle as well. I could make it say negative 2 pi over 3.